It says, explain why there must be a value C such that f double prime is 0. These types of statements are typically always referring to either the mean value theorem, the intermediate value theorem, or the extreme value theorem. This one is the least common, so I'm not going to think about that yet. So what you have to do is, again, as in most problems, all problems, pay attention to what you have, what you need. Okay, I don't have f double prime given anywhere. So it's not likely to be this. Intermediate value theorem is all about intermediate values of a given function. But I don't have any values for f double prime, so I don't think it's going to be this. Mean value theorem. F double prime is the slope of f prime. Therefore, the mean value theorem says that on a given interval, if the secant slope has some value, then the tangent slope will have that same value at least one place. So I'm going to go look at f prime and pay attention to the secant slope of f prime. So I notice that for f prime, from here to here, so from x equal -1 until I get to x equal 1, the secant slope is definitely 0, because the y-coordinate is 0 at x equal -1, and the y-coordinate is 0 again at x equal +1. So the secant slope between these two x-coordinates is 1. Therefore, because f and f prime, because f is twice differentiable, that means f prime is also differentiable. Therefore, the mean value theorem applies. So we just got to get it all written down here to get my points. The first point's pretty easy. Just show your computation of the secant slope of f prime. So here I'm taking the y-coordinate of f prime, subtract the y-coordinate of f prime, divided by the x-coordinates. You do have to show this. You can't leave it in function notation. That would get you 1 point for showing that. Now you have to have the key mean value theorem words. Should have boxed this. So let's fix that real quick. Maybe. There we go. Let's grab that one. So this needs to be boxed as well. We'll get it eventually. There we go. Okay, so that has to be boxed. You have to tell them why the mean value theorem is applicable. I really should have written f prime though. A little bit of a typo there. Since f prime is differentiable, that means f prime is also continuous, because the mean value theorem requires continuity and differentiability. Then you write the statement down here at the bottom. Therefore, by the mean value theorem, you can abbreviate if you want, MVT. And now you just copy their words right here. There must be a value C such that f double prime is equal to 0. Just copy that statement. If you have the green boxes, you get a second point for 2 total points. So summarizing again, this type of a statement pretty much can count on it being mean value theorem, intermediate value theorem, or extreme value theorem. Extreme value theorem is talking about an absolute min or an absolute max. So that's not what this is referring to, I don't think, and it wasn't. Intermediate value theorem, pay attention to, are they giving you the same thing they're asking about? So if I had a whole bunch of values of f double prime, then when they're asking about f double prime, I'm going to think about this. They didn't, so, because I don't have values of f double prime. So I thought mean value theorem because they do give me values of f prime, so I can find a secant slope of f prime, and if the secant slope of f prime is equal to 0, that means there must be a tangent slope on f prime, which is f double prime, that is also 0. So that's why I thought mean value theorem.